In this video, we are going to tell you how to identify outliers in the data sample using the interquartile range. Outliers are the data points that differ significantly from the other observations. There's various reasons why outliers can occur, and one of the reasons is that there might be an experimental error, some error in the measurements. In this case, we would like to exclude those values, those outliers, from the data set before performing any statistical analysis, because these values can cause serious problems in the analysis and bias our conclusions. An interquartile range, it's just the difference between the third quartile and the first quartile. And we will use this value for our method, even though there is various other methods to identify outliers, but this one is really simple. Let's define the following 4 points. The first one is the first quartile minus 3 interquartile ranges. The second one is the first quartile minus 1.5 interquartile ranges. The third point is the third quartile plus 1.5 interquartile ranges. And the last point is the third quartile plus 3 interquartile ranges. Now, if we have any data points in our sample that fall in the interval, in the first interval that are smaller than Q1 minus 3 interquartile ranges, or fall in the last interval, so if they are larger than the third quartile plus 3 interquartile ranges, those data points are considered strict outliers by this method, and they should be excluded from the statistical analysis. The data points that fall in the second interval from the left or the second interval from the right, so Q1 minus 3 EQRs from Q1 minus 3 EQRs to Q1 minus 1.5 EQRs, or Q3 plus 1.5 EQRs to Q3 plus 3 EQRs. Those points falling into those two intervals are considered soft outliers, also called conditional or contextual outliers. The decision whether these outliers should be excluded from the dataset or left for the further analysis, this decision has to be made by a specialist of that particular area who has some additional knowledge about the data, about the context where it comes from. Now, the data which falls in the middle interval from the Q1 minus 1.5 EQR to Q3 plus 1.5 EQR is considered so-called good data and will definitely be left in the further analysis. So let's take an example. Consider a data sample like this, with the values minus 1, 5, 8, 8, 9, 10, 12, and 25. To compute we have 8 numbers in the data sample, so the sample size is 8. To compute the quartiles of this data sample, we can either use the algorithm, the formula that was explained in the previous video on the simple basic statistics, or we can use the following algorithm. So let's first divide our data set into 2 parts, into 2 halves, and we have 4 values in each half, and let's take the mean value of the 2 middle values, 8 and 9, which is 8.5, and this will be our median, or the second quartile. Now let's take the left part of the data size, the left 4 values, and also take the mean value of the 2 central ones, And this will be our first quartile, equal to 6.5. And let's do the same thing with the left 4 values. We take this mean value of the 2 central values, which is 11, and this will be our third quartile. So it's the third quartile splits off the largest 2 or the largest 25% of the values from the data sample. And the interquartile range of this data sample will be equal to the value of the third quartile minus the first quartile value, and it's equal to 4.5. We will also need to compute 3 interquartile ranges and Q1 minus 3 interquartile ranges. So as with 3 interquartile ranges, this value Q1 minus 3 interquartile ranges will be equal to minus 7. Also, we compute Q3 plus 3 interquartile ranges, and this will be equal to 24.5. So now let's see if we have any values in the data sample that are smaller than minus 7. And we see there is no such values. And then we check if we have any values that are bigger than 24.5. And we see that we have one value like this, which is 25. So we, with this method, we identify the value 25 as a strong or strict outlier, which then will be removed from the data sample. Now, let's try to see if we have any soft or conditional outliers. For this, we compute the value of Q1 minus 1.5 VQR, and this is equal to minus 0.25. We also compute the value of Q3 plus 1.5 VQR, and this is equal to 17.75. Now let's check if we have any values that fall in the second interval from the left and the second interval from the right. So the second interval from the left is bound by the values minus 7 and minus 0.25. So we see that we have one value in the sample that falls in this interval, which is minus 1. So this will be our first soft outlier. Now let's check if we have any data points that fall in the second interval from the right side, which is between 17.75 and 24.5. And we see that we have no data points in the sample falling into this interval, therefore we have no additional soft outliers. So the conclusion is that from this data sample we could identify one strong outlier, which was 25, and one soft outlier, which is minus 1.